In this presentation, we're going to compute the variance for grouped data. So let's just scroll down here and look at the question we're going to be working with. This is based on a calculation I used to compute the mean. So the mean for grouped data. So this is following on from a different presentation. Just as a remark, the mean of this for this grouped data is 478.5. Okay, just as another remark, this is the frequency table, the column of frequencies, and the sum of those frequencies is equal to 100. That's the sum of frequencies there, and that value is equal to 100. Okay, so moving on. The variance of group data is given by this formula here. Now, it's quite a forbidding looking formula, but I'll just draw your attention to the fact that this part here is equal to x bar squared, just with that square there. So we've actually got quite a bit of work done already. So that's minus 478.5 squared. Usually when you're calculating the variance, you would have calculated the mean first. In fact, it makes no sense not to do it first. Also down here we have the sum of f, that's equal to 100. So all that remains is to compute this part here. Okay. The sum of fi, which is the frequency for each interval, times xi squared, that is the midpoint for each intervals, and you square it. So that's really the only new calculation you have to do to find the variance once you have the mean already. So what we're going to do is look at the example again. What we're going to do in the first instance is we have the midpoints. What we're going to do is square them. So the numbers here get quite forbidding looking. So 375 squared, 140625. The next one is 425 squared, that's 180625. Next we have 475 squared, that is 225625. Next one is 525 squared, so we get 275625. Lastly, 575, squaring that we get 330625. Now, these numbers get big and there's just no way around that really. Next, what we're going to do is compute the product of each. So for each interval, we're going to multiply f by x squared. So in the first instance, we're going to multiply 14 by 140625, and so on. So 1968750. Okay. Next one is 3431875. Next one is 6994375. The next one is 496150. And lastly, we have 5951250. Now what we're going to do is add up all the values in this column here and sum them up. So what we would get in that instance is 233,07500. So this number here is absolutely huge, but unfortunately there's absolutely nothing that can be done about it. When you're calculating with variances, you just get big numbers. So we're going to sort of save that, and now what we're going to do is move on. We're going to sort of calculate the mean now, or the variance, and we're just going to put all our numbers together. So we have, this is equal to 23307,500, and we're going to divide that by 100. And what we're also going to do is subtract that for the mean and squared. So this is a bit of calculator work. What we could do here first off is just divide that out divide both values, or top them, or divide the left hand side by 100. So it just simply simplifies out that we get left with 233,075. So this is equal to 233,075 minus that squared. We would get 228,962.25. Okay, and that is equal to 4112.75. So that is the variance there. That's our answer down there. That's the variance. What we could do, lastly, is to compute the standard deviation. The standard deviation simply is the square root of that. So the variance, or the standard deviation, S, is simply the square root of 4112.75, and roughly, approximately, that's equal to 64.13. So that is the standard deviation. And that